myself Nabashi, and today I'll be talking about my project on sustainable agriculture. Where should I sit? Over there. Okay, I'm ready. Shall I start?
Okay.
Okay, so today we are talking much on environmental problems. We know that we are destroying our planet for human prosperity. Native ecosystems, whether it be on land or in the sea, are lost by negative impacts of human activities. We know that there is massive destruction of rainforests going on, and other native flora are lost day by day. Also the loss of genetic diversity, especially in large mammals, birds, amphibians, and cultivated crops. Vascular plants in 21st century are disappearing faster than the natural extinction rate by 500 to 1,000 times. Most of biologists are considering that the sixth massive extinction in Earth's history is going on. The degradation of topsoil and the loss of vegetation cover is serious. We know that 70% of arid arable lands are exacerbating the desertification, and 1 billion people are affected. By 2050, several hundred million people could be forced to migrate because of the critical state of the soil. When we lose life on land, we also lose life in the sea. We know that marine ecosystems are suffocating by the pollution of water systems. Fish are choking and corals are bleaching by eutrophication. I myself measured fish species richness along the coast of a small island in Japan and discovered that it was negatively correlated with river outflows. Material cycles are disrupted and exceeding planetary limits. Nitrogen, phosphorus, and carbon cycles have already exceeded the stable operating ranges of the Earth system. It may not recover naturally even if we stop the exploitation. Scientists are raising high alerts on increasing risks of uncertainty, on climate change, and on global ecological state. We may soon experience sudden disruptive and negative changes in our living biosphere. Once it happens, it may not recover naturally because the fundamental integrity of the biosphere is broken apart. It may take a long time to recover, to reseat the collapsed building blocks of ecosystems, with the condition that human activities should shrink to a level before industrialization. All these have a common major cause, which is the inappropriate practice of agriculture, especially monoculture intensive farming of any scale. Land conversion for agricultural use, logging, then tilling, destroy the surface vegetation and soil structure. Without the natural function of soil covered with vegetation, application of fertilizers and chemicals on bare lands run off directly to water systems. It is like pouring water into a leaking bucket. We need to invest materials and energies much more than actually needed to maintain the artificial fertility of soil and eliminate weeds and pests. Agriculture in industrialized nations use more fossil energy for producing food than the food energy produced. In Japan, in US, in European countries, quite possibly in other countries as well. Furthermore, the current distribution systems consume even more fossil energy than the production processes. The intermediate revision of biodiversity targets in 2014 sets forth the importance on the fundamental reconsideration of consumption habits, especially the large-scale change of food systems around the world is needed. We need to create alternatives that should replace a substantial part of our food systems with sustainable modes of production and distribution. We need to harness our exponentially growing economy into a sigmoidal plateau which keeps our activity within the planetary limits of available resources. We know the fundamental problems are there. Then the question is, what should we do? I started with what I could. I was majoring in complex system science in my PhD and studied on how living systems such as our brain, our body, and our society are organized and functioning in a beautifully coordinated manner. For me, it was a natural extension to think about ecosystems as an advanced topic of complex systems science. How complex vegetation develops and ecosystem functions emerge. So after finishing my PhD in physics, I went back to my hometown and discovered a piece of land that belonged to my family. This is what it looked like on January 2010. Yes, I started to sow seeds and plant trees on that bare land. This land, my ancestors have protected and inherited for more than 400 years. It used to be coastal pine groves and marshes, and since the foundation of Japan is based on rice agriculture, this region was traditionally covered with monoculture paddy field. But urbanization has led to replace most of the rice fields into houses, and my family kept the last fragment of the rice field that existed until my childhood. I wanted to protect this land as a farming plot, but as a native to this place and scientist, I put some question. What kind of crops other than rice could this place actually accept and grow if we need to tackle biodiversity and resilience of agro-ecosystems? What is the real potential of this land in terms of the diversity of the product? So I started sowing and growing as many crop species as I could find in local garden stores and online nursery companies. The bare land has gradually covered vegetation with edible crops and various useful plants without any application of tillage, fertilizers, and chemicals, leaving it in a completely natural growth of plant communities other than occasional harvest and mowing. The vegetation developed from grassland to bush, and today, it looks like a jungle filled with a wide variety of edible plants and other small animals. This land introduced more than 400 varieties of edible plants. It may be the most concentrated biodiversity ever existed in this place. Lots of insects emerged and are making up a formidable food chain. They are controlling the environment as natural predators, pollinators, and enriching the diversity of plant communities and soil quality. Some plants have disappeared, but others settled and formed their ecological niches. And harvest by thinning out from vigorously grown plants provided us a gorgeous variety of produce. During that experiment, I also collaborated with a professional farm of market gardening, and they have produced more than 80 kinds of products distributed to more than 6,000 consumers all over Japan. And the sales on 1,000 square meter was more than double that of conventional farming methods. Our ecosystems were remarkably robust and resilient to abnormal weathers that are becoming more frequent in recent years, by which conventional productions experience crop failure. I thought, here is the next program for agriculture, how to make use of this potential diversity given to us, endowed by the beautiful climate of Japan. After more than 2,000 years since the foundation of this country with rice agriculture, we achieved zero hunger in 1960s. But this has led high-impacting monoculture methods to dominate food sectors almost for all basic commodities such as vegetables and fruits. Now that food quality, climate change, and biodiversity loss is in question, we need to reconsider how to recreate ecosystems and people's consciousness and build cultural solutions to achieve sustainable food production. I believe this problematic is common in all countries where monoculture production is dominant, not only for cereals, but other basic commodities and animal feed. The good news is that we can start from the small scale, like in my plot, instead of blaming large-scale producers. Actually, more than 90% of the basic commodities in the world are produced from small to medium-scale farms, and family-owned small-scale producers cultivate on 80% of the world's arable land. Large-scale productions are also problematic, but as a matter of fact, they produce only 20% of food at the present time. It is not scalable because the resources are limited. For most of smallholders, the essential conditions for implementation are small-scale, diversified practices adaptive to local environments that do not require heavy machinery and other material resources such as fertilizers and chemicals. Here comes the conception of synecological farming, or Synecoculture, as a fruit of our complex systems experiment. It relies on the biodiversity and the spontaneous productivity of dense and mixed edible plant communities. This is compatible with the way land ecosystems have evolved and are continuously adapting to environmental changes through ecological successions. Synecoculture further augments these natural processes through the introduction of various edible species. It is a no-till, no fertilizer, no chemical, no heavy machinery practice. We control and diversify ecosystems by the strategic introduction of edible plants and by thinning harvest. We introduce more than 200 species in 1,000 square meters, which is far beyond the diversity of naturally occurring plants. If I talk as a scientist, there is a complex system theory behind. Monoculture productivity can be maximized only if the environment is stable and close to the isolated growing condition of the crop. It requires material resources and produce environmental impact as a trade-off between productivity and biodiversity. This is what traditional agriculture has been doing. In contrast, when the material resources are limited, the climate is irregular and external disturbances are strong, such as pests and invasive alien species, it is better and safer to produce as a highly diverse mixed community. This is the way of Synecoculture. It can be more productive and cost-effective in small scale and provide various products synergistically with the increase of biodiversity. Looking at this theoretical figure, another idea came up to my mind. What if we try this system in extreme environments? Because the theory tells that Synecoculture could excel in marginal environment where monoculture solutions deviate far from optimal. Seeking this possibility, I went to sub-Saharan Africa, in Burkina Faso, where I literally found the desert, which is the combined consequence of climate change and deforestation by agriculture pressure. Here, there's no rival. Conventional monoculture was wiped out because it was no more possible to practice in such a barren land. We collaborated with local NGO and installed Synecoculture on an abandoned land where there was no vegetation and did not recover naturally. We planted about 150 kinds of edible plants in a dense and mixed formation. And within 1 year, the land has established a rich vegetation full of vegetables and tropical fruits. It was not possible with other conventional methods. Usually in such a harsh local climate with drought and scorching heat, crop failure is frequent in monoculture systems. But in Synecoculture, because the ecosystem is multi-layered and thrive on complementary effects, the vegetation is vigorous, the soil is restored, the microclimate is regulated, and products are of high quality. We sold our products on local market. Out of the experimental farm of 500 square meters with one worker, we were able to earn about 40 to 150 times sales compared with the national statistics of monoculture productions. It corresponds to 20 times the gross national income per capita of Burkina Faso. If we take the average, only 10 square meters of Synecoculture could produce the minimum wage for a person to live in the capital city. We could definitely say that Synecoculture has a huge potential to positively impact biodiversity and boost local economy in Sahel countries. It continues to grow and expand. We organize 3 scientific conferences gathering stakeholders and experts in related fields. You can find the proceedings on the web. We also launched a new research and training institution to use Synecoculture as a powerful tool to address problems in sub-Saharan countries such as poverty, environmental destruction, and even peace building. Now, let's look at our internal world, how the food affects our metabolism. Health effects. This is also where biodiversity plays an essential role. We found that the green tea produced by Synecoculture contains lots of bioactive compounds such as flavonoid. This figure shows basic metabolic pathways in our body, on which I plotted with red points highlighted with orange circles phytochemicals that were highly expressed in Synecoculture tea compared to conventional tea from the neighboring plots. It is spread over a wide range of our basic metabolism, and this implies that the biodiversity in culture environment stimulates those expressions in tea plants, which could eventually support long-term health protective effects on humans. I went on to get the exact evidence on human. We collaborated with a rehabilitation center and tested the effect of double-blind intake of Synecoculture tea and conventional tea on more than 100 people. We measured the functional independence measure, or FIM, which is an 18-item measure for physical, psychological, and social function. It is used to assess a patient's level of disability. The results were somewhat disruptive to the common sense of rehabilitation. Patients who took Synecoculture tea significantly and selectively ameliorated the FIM scores. Synecoculture tea is not a medical drug. It is simply grown amid the rich ecosystem with bountiful interactions with other plants and animals, and these environmental effects bring exceptional benefits to our well-being through food. Think about it. What we are putting at stake is not simply the diversity of nature, but it is also a fundamental support of our health. Although it is difficult to reveal the microscopic mechanisms of this complex system, the overall cumulative effect should be explicitly put in the definition of food quality. This can be done by assessing the way biodiversity is organized in cultural environment and relate to the net health effect of the product. Now that the next challenge needs to resolve the health, diet, environment trilemma. It is a hard core of the sustainability problem. It is rather a renovation of social economical systems more than ecological systems. How can we secure and promote the good practice of smallholders in a way constructive to both social and ecological systems without putting them in the risk of going against economical incentives? How can we avoid the conflicts with large-scale mechanization pressure and overcome inequitable regulations on the access to genetic resources such as seed laws? I think that's the key is, again, the diversity. How to empower our intelligence to make wide use of the huge diversity of plants, crops, animals, foods, marketing, and distribution processes. It is the matter of how to yield excellent synergy out of megadiversity. As we have seen in small plots in Japan and Africa, nature has its own potential, and we humans should catch up with the language of megadiversity if we want to accomplish a new form of sustainable prosperity. Here comes the conception of megadiversity management systems, which is a supportive tool of Synecoculture and related social ecological processes using information and communication technologies. We need to construct massive databases of edible plants and animals, its utilities such as recipes, medicinal uses, and health effects. We observed more than 1,000 plant and insect species in Synecoculture plots and surrounding environment, including IUCN red list species. Synecoculture is the creation of a new ecosystem augmented by human. The introduction of diverse useful plants further stimulates the emergence of various natural species, and it can create ecosystems with higher species richness and abundance than natural preservation alone. Then, to cope with the overwhelming amount of ecological information, interactive interfaces are necessary to explore the big data to apply in the field. This is, for example, the estimation of herb species in our field in Burkina Faso, and what kind of plants we can further introduce as herb species that would strengthen potential pollinator networks. We further need help of artificial intelligence and machine learning. To control the biodiversity in a cost-effective way, we need to reveal its self-organized maintenance mechanisms and emergent ecosystem functions out of the big data. This is the very core of the synecology, or community ecology, that makes the theoretical foundation of Synecoculture. The results can be visualized interactively on site and reduce the cost of the management through the use of augmented reality, and can be remotely accessed and collaborate with virtual reality technologies. Useful ecosystems can be easily replicated by copy-pasting of virtual guiding information. To establish healthy local economy with smallholders, we need to reconsider the distribution network. In order for the small producers to live on primary food production, I believe it is necessary that more than 2/3 of the market price should be returned to producers. This is impossible with conventional distribution systems where small numbers of big supermarket chains, agricultural corporations, and seed companies are dominating as intermediaries. We need to convert the structure of our society into a decentralized autonomous organization working on peer-to-peer transaction directly between producers and consumers. Their various matching and exchanges between mega-diverse products and services could be executed with online technologies precisely on what we need and when we need. This will be possible by combining the mega-diversity management systems with emerging internet technologies such as smart contracts. It is a computer-supported peer-to-peer transaction system without intermediaries and is secured with decentralized security protocols such as blockchains. To realize the bottom-up agricultural revolution, we launched the Food Flagship Project in the UNITWIN UNESCO Complex System Digital Campus Program. I believe this is the most efficient one in history. It aims to combine mega-diversity management systems and smart contracts to realize the ICT support for the peer-to-peer collaboration in decentralized autonomous organization of world food producers, which count up to half of the world population in the largest estimate. We need to construct the efficient hierarchy for the open source strategy of development and implementation. We estimate that we need to realize the scale of 2,000, which is to construct a development community of 1,000 members, and one developer deploys a software that can be used for 2,000 rural engineers who will each provide consultation services to 2,000 producers. It is not impossible. If we look at the success of other open source projects such as Linux, there are almost 20,000 developers committed to the kernel. And this goes beyond the food production, but any fields where mega-diversity plays essential roles. Synecoculture is not a sector-wide replacement of conventional food production, but a fundamental renewal and reconstruction of unified sustainable model. This is the word cloud from the keyword of the stakeholders who showed interest on mega-diversity management systems. It is extensive over more than 20 industrial sectors and academic disciplines. For this reason, we take a transdisciplinary open source development for mega-diversity management systems. When we talk about mega-diversity in the world, we mostly imagine the mega-diverse countries. Mega-diverse countries are a group of nations that contains more than 70% of the Earth's biodiversity. There are 70 countries registered, but you would say that it is also the matter of the surface. Big countries should contain more biodiversity than small countries. Japan is rich in biodiversity, but it is too small, it's not in there. As a complementary measure, we have the biodiversity hotspots. It is the regions with significant levels of biodiversity, but that are threatened with destruction. Yes, Japan is in there. To apply mega-diversity management systems and support Synecoculture, we need access to internet. You can see that there are actually wide overlaps between the internet access points and biodiversity hotspots. Mega-diverse countries also possess abundant ICT infrastructure. These overlaps are increasing, and it is the frontier of our fight towards sustainability. Looking from this perspective, there is a new importance for small and special countries and regions. Not only the big mega-diverse countries, but small countries located in a particular climate region with endemic ecosystems will play crucial roles. They are the true body of mega-diversity. As we have seen with the experiment in Burkina Faso, small countries and regions with small producers with particular environments can be the source of an essential breakthrough. Because the condition is special and even harsh, the contribution is high as the particularity and scarcity of information. What we can realize with Synecoculture and mega-diversity management systems is the formation of new ecosystems. which are rich, diverse, useful, and valuable both for human nature beyond the uncontrolled natural state. It is a human augmentation of ecosystems, and small and special countries are perfectly suited for this challenge. Small countries can be good actors because public and private sectors can be tacked more closely. Small countries are sensitive to environmental problems because they are more susceptible to negative effects in short term. In the field of science, there is a good example of small and special country. Sweden is known to host the Nobel Prize Committee, which has largely influenced the history of modern science through the awarding activities. Sweden itself may not be the biggest and strongest country in terms of the scientific achievement, but it is definitely a special country. Similarly, small and special countries could play essential roles to resolve the sustainability problems not only for themselves, but for bigger megadiverse countries by providing leading solutions. It is one of precious gems adorning the future of the earth. And Synecoculture is awaiting to be a part of the new landscape in small and special countries to work with good-willing citizens and far-sighted policymakers anywhere in the world to establish a long-lasting bond between human and nature. And thank you for listening. So I finished. Thank you.